So we've taken curly and we've added cons and first and rest and quote and so on. And now we want to add let macro, where the general form is the name that we bind to the implementation of the macro and possible uses of the macro. Macro is just something like delay. It takes an S expression and it produces an S expression. And by binding delay using let macro, then we can use it in the body here, a delay of 7, and that'll get converted to a lambda that takes a dummy argument and returns 7, right? By the dot dot dots left out here. Another example would be let macro of let. So here, instead of making let built into our parser, we're going to just leave it as something that you might implement yourself in curly as a macro. And so with let being bound, then this let gets converted to the usual lambda pattern, right? You can see that the result of the let macro should be the result of its body. So we want this form to turn into whatever let expands to. And in fact, once we've finished parsing, then there's nothing left for let macro to do. The job of let macro is to affect the parser so that this let form gets rewritten. Once it's rewritten and we start interping, we're not parsing anymore, and so let macro goes away. So to implement let macro, all we have to do is change parse, not interp. So let's look at let macro in parse. Let's use our delay example here on the side. So in general, parse needs to match a let macro form where there's a symbol, any expression, and any other expression. So the symbol here is delay, the first any expression is the implementation of delay, and the last any is the use of delay in the body of the let macro. As we said, the result of this let macro, it should be changed into whatever its body expands into, whatever its body parses to. So we're going to call parse on that third of the S expression S. That's the essential result. That's the main result. Meanwhile, though, we need to deal with this symbol in any. We'll let B's, as usual, refer to these two pieces, symbol and any. And so the symbol part there, that's going to correspond to first of B's as an S expression, and then we convert it to a symbol. What is it that we want to do with this symbol delay, though? We want to arrange for delay to affect how the body is parsed here. Right? So that name should somehow affect this call to parse, which means, as we've seen this before, when a name needs to affect something else, then we handle it with an environment. So we're going to change parse to parse star, slightly different parse star than before, where it takes an environment as a second argument. And let macro's job is to take this symbol, like delay or let, and bind it in that environment. What does it bind it to? It's supposed to bind it to a function implemented here that takes an S expression and produces an S expression. So that function is this any expression here. That's the second of B's, which we can parse. When we parse it, though, we don't get a function back. We just get a lam e, right? To turn that lam e into an actual function that we can apply to an S expression, we need to interpret. And at this point, some alarm should be going off because we've always said that parse should not call interp. We've kept them separate up until now. But this is exactly the ingredient that makes our language extensible. It's that parse does call interp in the process of parsing. Right? So that's where the extra power is. That's where the ability to extend the language comes from. Crucially, though, this call to interp, it uses an empty environment as the second argument. And what that does is make sure that this function, which is being run at parse time, doesn't try to use any of the environments that surround it. Those will only exist at runtime, which is later. So it can only refer to variables that it creates inside of itself, right? That's why we start with the empty environment here, and that enforces a separation between parse and interp that makes everything work out. So now that let macro has bound delay to one of these forms, let's look at how that delay binding is used in the environment. So that would be when we are expanding the delay form. That's going to match this pattern in general. There'll be sort of any sort of name and then anything after it. In fact, it overlaps with the pattern for function calls. So we're going to have to handle that possibility here as well. This might be a function call matching this pattern, or it might be a macro use, like using delay or let. So what we do is we look at the first thing here, and I'm calling that rater. And we're going to look at rater and try to work with it. But if all else fails, in other words, if we're not able to use it as a macro, then we'll parse it as an appy. Since we only have single argument functions, though, then we need to double check that, in fact, there's only one any argument here, or exactly one. The overall length of the expression has to be 2. If so, then we'll do the usual appy. So that's just handling the API case. The interesting part here is handling when, in fact, it's an identifier bound to a macro. So what we will do is we will try to look up that identifier in the environment. And if it's not even an identifier, that will be an error. If it's not in the environment, the parse time environment, that will be an error, and we'll handle it as a function call. But if it is a symbol that's bound in the environment, then we'll get a macro function out. That macro function takes an S expression and returns a new S expression. So we give that macro function S, which will correspond to something like delay of 7, and it rewrites it into something like lambda dummy return 7. Whatever it rewrites is still an S expression, and so that's still something that we need to parse again. So we call parse star on the result of apply macro, and then it recurs and just keeps parsing and expanding for us. That leaves us needing a helper function, apply macro. Apply macro, though, is fairly straightforward. The transformer function, it's going to be a curly value, but it has to be a closure. If it's anything else, then that means you use let macro in a weird way. But as long as it is a closure, then we can interp that closure. We can call that closure using interp, binding the argument to the S expression that we're given. But of course, this S expression right now is a plait S expression. We need it to be a curly S expression. We already have a helper function that does that. When we get an interp result, it's going to be a curly S expression, and parse star to continue will want a plait S expression. So we convert it back as a result. So there's this bridge that goes from the parse world into the curly world and back into the parse world, and that's an essential feature of our macro expansion. If we put these all together, then an example like this will work. So here I'm letting the macro delay take an S expression and rewrite it into lambda take a dummy argument, and then these parts pull out the body of the delay and put it as the body of the lambda. Force is also a macro, although it could be a function, but here I've written it as a macro that rewrites things to, here I'm using cons, but what you don't see is I'm building up a function call, right? This is just going to be something applied to 0. So this ends up rewriting force of something into calling that something on 0, which is the dummy argument that a delay thunk expects.